Hey there, I'm Will Katz. This is Precalculus 3.2, and we're going to be doing problem numbers 10, 11, 12, 14, and 26. So here we go. Three point two is like 3.1, but it has way more factoring. And some of the strategies you'll see me use and you'll use to do this section are common denominators. Factor out a monomial, and what that looks like is if you have like xa plus xb, you could factor out an x to give you that. You're going to be a lot of distributing or foiling of monomials, and this section also introduces some more advanced factoring, and I'll show you what that looks like. There's a couple that they give you that are difference of squares. So this one with x squared minus y squared, and this one with x to the fourth minus y to the fourth. You should already know this, and if you don't, just go ahead and memorize that. Now here's one that you probably haven't seen before, which is the sum or difference of cubes. So if you have x cubed plus y cubed, that factors into this. And the way that you can remember it is know that with x cubed plus y cubed, the first term is going to be x plus y. And with x cubed minus y cubed, the first term is going to be x minus y. And whatever the sign is of the first term, it's going to be the opposite of the sign of the middle term of what comes after. So you can see here there's a plus, and there's a minus, and here there's a minus, and there's a plus. So with these, I really suggest you memorize these, because if they give you one of these on the test, and you know this stuff by heart, it's easy points. But if you don't know it, it becomes a big issue because you have to kind of like figure it out on the fly, which is pretty tough. So that all being said, let's dive in and do some problems. So I've picked 5 problems, and each one is going to be of it'll kind of show you the different types of problems that occur in this section. All right, starting off 3.2, number 10. Okay, right off the bat here we have a difference of squares. So what that's going to give us is secant squared beta minus tan squared beta times secant squared beta plus tan squared beta. And if we look at our trig identities, we can see that secant squared minus tangent squared equals 1. So we're just going to go ahead and replace that term with 1. So what that leaves us with is secant squared beta plus tangent squared beta equals 1 plus 2 tangent squared beta. So we're actually almost there already. What we need is a way to convert this secant into 1 plus another tangent. And fortunately, we have a way of doing that. If we look back at our trig identities, one of the major ones here is that secant squared is the same as tangent squared plus 1. So we're going to go ahead and replace that. So this secant squared we're going to replace with tangent squared beta plus 1, and then we have that leftover tangent squared beta. And you can see that we're obviously there. That's it. All right, so that's one type of problem. Moving on, we're going to do number 11. Okay, whenever you see these problems, 9 out of 10 times what's going to happen is each of these is going to factor into a cosine times a cosine situation. And the challenge becomes, how do you factor these? Well, what I want you to do is look at the right side and assume that each one of those is going to be a factor. So I'm just going to take this cosine w plus 1, and I'm just going to put it right there. And I'm going to take this w minus 4 and put it right there. So if we assume that each one of these is a factor, then it becomes pretty easy to figure out what the other factor is. So for this one, if this one's cosine w plus 1, that's going to give us 1 cosine w, and we need another cosine w to make 2. So I think that both of these are actually cosine w plus 1. Looking down here, if we have a minus 4 on bottom, so we need to get to a minus 4, so that's going to be times a plus 1. And this is kind of what we expected, because what that's going to mean is that these cosine w's plus 1s are going to cancel, leaving this. So that's how you do these. Assume that these terms on the right are going to be factors in the factorization of these terms on the left. Double check that that's actually true, like go through it in your head, and then just cancel them and you're done. All right, moving on, we're going to do number 12. Okay, right off the bat, looking at this one, we have a difference of cubes. And so you want to memorize that formula. So what we get with that is cosine A minus secant A times cosine squared A plus cosine A secant A plus secant squared A, all over cosine A minus secant A. And what's nice about this is right off the bat, these two things cancel. So then we're left with this. So we need some way to make this look like that. So right off the bat here, cosine is defined as 1 over secant. So if that's true, then we can actually just, this term right here just becomes 1. So that's really cool. So let's go ahead and rewrite that. Cosine squared A plus secant squared A plus 1 equals that. So we needed a way to turn cosine squared A and secant squared A into a negative sine A tangent squared A plus 3. So what we're going to need to do here is look at our trig identities. So cosine squared theta is the same as 1 minus sine squared theta. So that gives us our negative sine A, and it gives us another 1 that we can add to that. So let's go ahead and replace that. 1 minus sine squared alpha. And secant squared is the same as tangent squared plus 1. So that's how we go from our secant squared to the tangent squared we're looking for. And I think that gives us our final one that we need. Our final one that we need as well to make 3. So I'm going to go ahead and replace that. And here's our 1, 2, 3. There's our negative sign, and there's our tangent squared. So we are good. All right, moving on. Let's take a look at number 14. And this is a little bit of a twist on the type of problem we saw in number 11. Okay, so this looks like a basic binomial factorization problem, but the challenge is that we don't have all of it in terms of sine. We have sine squared. So what we're going to do is replace sine squared with 1 minus cosine squared for both of those. So then we have 2 times 1 minus cosine squared over 6, 1 minus cosine squared. So I'm going to go ahead and distribute. What that gives us is okay, so now we're finally at a point where we can factor this stuff and have it be productive. So same strategy as before. I'm going to look on the right and assume that each one of these is a factor. So let's go ahead and put those in there. So let's assume that cosine W minus 3 is a factor, and we'll assume that 3 cosine W minus 4 is a factor. Okay, so if we assume that these are factors, okay, so this is going to need to be a negative 2 cosine W to give us the negative 2 cosine squared W, because we're multiplying it by a singular cosine W. So that's going to give us that. And it's also going to give us plus 6 cosine W. So to make a plus 3 with a minus 3, we're going to need a minus 1, because minus 1 times minus 3 is plus 3. And that's going to give us the minus 1 cosine W that we need to put us at 5. Okay, so now looking at the bottom factor, 3 cosine W, to make negative 6 cosine squared W, we're going to need a negative 2 cosine W. And to make a plus 4 out of a minus 4, we are going to need a minus 1. And this works out really nicely because these are the same. So we can go ahead and cancel those, which leaves us with what we were trying to get. So that's how you do that. All right, last but not least, we're going to do number 26. Alrighty, so looking at this one, this is going to be a gigantic factorization problem. So let's get started with that. So the first term, we're going to have a secant x paired with a secant x. And then we need 2 factors for 10 that combined give us a plus 3. So I'm going to say 5 and 2 sounds pretty good. So we need a plus 3, so we're going to make it a plus 5 and then a minus 2. Alrighty, so moving on, we have secant squared x, so again that's going to give us a secant x and a secant x. And we need a minus 7 from the factors of plus 6, so that's going to give us a minus 1 and a minus 6. Moving on. Now we need, let's see, we have secant squared, so again it's going to be a secant times a secant. So we have a minus 3, and we need the factors of minus 3 to give us a plus 2. So that's going to be a plus 3 and a minus 1. That multiplies to negative 3 and adds to plus 2. And finally, again, we have a secant squared, so that's going to be a secant times a secant. And we have a minus 6, and we need to pick the factors of minus 6 to give us a plus 1. So I think that's going to be a plus 3 and a minus 2. Those should multiply to negative 6, but add to plus 1. So now we get to canceling stuff. So here's a secant x minus 1. There's a secant x plus 3. And there is a secant x minus 2. So that leaves us with secant x plus 5 over secant x minus 6, which is exactly what we were looking for. Boom. So stuff like this is kind of just, are you able to factor binomials quickly and effectively? You can do it the way I did it, which is just to kind of think about it and think about the factors of the C term and how those would add to give you the B term. Or if you want, you can do the X box method that you may have learned. So that's number 26. So that should pretty much cover all the different types of problems. Again, if you have any questions, leave a comment down below. If you like this video, go ahead and subscribe. And if you need to reach me for any reason, my contact details will be in the description. So this has been Will Katz. Thanks, and see you next time.